Hello and welcome to Moxa's webinar covering PoE basics and trends in the industry. I'm Martin McHugh and I'll be your moderator today. If you have any questions at any time during the webinar, please use the questions pane by simply typing in your question and clicking send. At the end of the presentation, we will do a Q&A session and take as many questions as we have time for. We will follow up with any unanswered questions after the webinar. All right, let's get started. We'll have 30 to 40 minute presentation with 15 to 20 minutes of Q&A. Today's presenter is Jim Tepper. Jim is the Business Development Manager for Power and Latin America here at Moxa. With that, I will hand it over to Jim.
Well, thank you, Marty. I do appreciate that. And good morning and good afternoon to all of our attendees on the webinar today. My name is Jim Tepper. I will be going over Power over Ethernet as a topic. Now, of course, this Power over Ethernet topic is specifically targeted at industrial automation. Looks like we've got a great number of people in the audience today, and I do appreciate everybody attending. Well, with that, let's go ahead and get started. The agenda for today is pretty simple. We're going to cover PoE, what and why, PoE trends in automation, some of our solutions because you don't get to get away from here without at least a plug, and then of course some PoE applications, just a little sample set of what's available out there. Okay, so PoE, what is it and why? We're not talking about Edgar Allan Poe here. We're actually talking about PoE, so there will be no talk about the Raven or anything like that. Hopefully there wasn't any misinterpretation. This PoE is Power over Ethernet. And with that, I would like to see kind of where we are in our audience with our first poll. The poll is, how much experience have you had with PoE? I'm kind of curious to see what kind of, penetration we've seen out there in the market. So go ahead and take that poll and see what we can do. All right, so what do we have here? It looks like we've got some really good numbers here. So far, how many people? We have 69% voted. Go ahead. Come on, get in there. Let's vote. Let's get to 70, 75. Okay, good. We've got a lot of people that have gone ahead and done this quick poll. It looks as though the majority of you have had very little experience with PoE. Only 30% have used it some of the time, and only 11% use it all the time, and it looks like 4% of you are Edgar Allan Poe fans, so meaning that you've probably never used PoE before. So I do appreciate you guys taking the poll. There's going to be 2 more polls as we go through this presentation. It'll help me craft it and make it a little bit more personal to all of you. So thank you very much for participating in that poll, and with that knowledge, I think you'll find this presentation is very applicable, because we're not going to go too deep in the technology, but for those of you who have had some experience with it, we're going to do maybe 1 or 2 technical slides on how it works. For those of you who haven't used it much, haven't used PoE much, or have very little exposure to it, you can kind of see the trends over time in the amount of PoE ports that have shipped. Whether it's a powered devices that are taking power from PoE, or it's a power supplying device or power sourcing equipment device, you can see that there is pretty substantial growth, and in some instances, some surveys put that growth as high as 55% year over year. That's a large amount of growth, and that's actually pretty impressive. And in the industrial automation industry, we have seen the addition of several new types of devices that have been coming into the market. So it does behoove you to check it out. And well, why and what, I guess? Why would you use PoE? What's the big deal, really? And it is actually a pretty big deal. With most applications nowadays, you will see almost 100% adoption rate on wireless and cameras for PoE. And the reason is simple. If you put a camera up on the top of a pole and you plug it in, you know, it's just a hassle to run extra power wires all the way up that pole just to power that device. Wouldn't it be nice if you can just run one cable that does the data and power, and that cable can be a standard Ethernet cable? And that's kind of the reason behind it. Now, access points are the same way. We don't tend to have access points sitting on our desks where they're easily accessible. Most of the time they're on the ceiling, up in the rafters, on a manufacturing floor. You'll have them up maybe zip tied to a girder or something like that. It's nice to be able to run just a regular old Ethernet jack to it and make sure that it works that way. But also for other reasons, there's a lot of savings to be had with PoE. You can save on power supplies because you won't need a power supply at the end device. You can save on cabling. You can have less heat and less power consumption, so in general you're saving on power. You're saving a lot of space in a panel if you're an OEM or a machine builder. The panel is usually a very valuable commodity per square inch, so not having to put an extra power supply in there could be very beneficial. You can save on the amount of power runs you have. Why would you want to hire an electrician to go onto your factory floor, run a conduit for 220 or a 110 just to put it into a power supply that converts it back down to, a 24, 48 volt DC just to power an Ethernet switch? A lot of times excuses have been, I don't want to put a network in because I have to run, conduit, hire a contract. It's going to be way too expensive, just the logistics. So with PoE, you can get around that. And of course, it is much faster. You plug it in, your device turns on, and just starts working. That's probably the most fantastic piece of it. Now, let's kind of elaborate a little bit more on the benefits of PoE. You do have power and data over that same Ethernet cable. You don't have to have a special Ethernet cable. You don't need a proprietary bus. You don't need purple pipe or yellow pipe, anything like that. Just a plain old Cat5 Ethernet cable. You can use Cat6 as well. Pretty much everyone runs Cat5 and Cat6 nowadays, so I think that's going to cover about 99% of people. It's really easy installation, as I had mentioned, of course, and you do lower your maintenance cost, lower your maintenance and installation costs, because now you have just one cable to worry about. So, in a non-PoE situation, your installation might look like this on the left-hand side here. It's pretty simple. You've got an AC/DC power supply that's plugged into the wall or into AC somewhere. And it's making DC current that's powering your non-PoE industrial switch. And that industrial switch is then connected by an Ethernet cable. It's connecting to an end device. In this case, it's an access point. And this access point in this example is not PoE, so it does require a standard power supply as well. So you're buying two power supplies, and you're connecting it up, and that's your non-PoE solution. Well, that's pretty standard. That's pretty much what everyone uses today. Now, if you look with PoE, you're eliminating that power supply. You're using a PoE switch instead, and you're providing data and power on that same Ethernet cable that you were going to use before. So the concept is pretty simple. You're eliminating the need for additional pieces to the solution, and you're providing a very quick installation with a standard Ethernet cable, data, and power. Okay, so now that we have kind of identified the basics, the very, 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 very basics of power over Ethernet, we need to make sure you understand some basic terminology too, because this will help you in making sure your PoE initiative is successful. So we have two terms that are a must in this arena. One is called PSE, and one is called a PD. Now, the PSE is the power sourcing equipment, or you can think of it as the device that sends the power. In most cases, this is just an Ethernet switch or an Ethernet injector. Now, Moxa has a very unique offering. We have a media converter that actually provides PoE. So you can go fiber in and PoE copper out. So, there are a lot of choices for providing power. And of course, the PD is just the device that's taking the power. And the PDs are probably the coolest piece of it all. There's access points, there's cameras, there's even device servers now. We make a serial to Ethernet device server that can be powered by PoE, thus eliminating the need for a wall wart and additional power supply. So those are the two main terms there. And don't forget, with PoE, it's important to know that the distance limitation is the same as standard Ethernet. So you're looking at 100 meters or 330 feet approximately for your distance there. So you don't have to memorize anything new for distances and whatnot. Just cable it like you would any other Ethernet device. Okay, so let's talk about a PoE injector. How does this PoE injector work exactly? Well, you have a standard industrial Ethernet switch, or even a, maybe it's in your control room and maybe it's a rack mount switch that's, plugged into the wall, whatever. And you have data coming from that standard switch. But you have a PoE device at the end there, a PD. Remember, we just named that PD. And you need it to have a PoE signal. So how do you accomplish that? Well, you can simply put a PoE injector in between the switch and the device on the end. And that will allow you to have the PD being powered up. But in this scenario, of course, you do have to remember that injector does have to have power, so you do need to have a power supply for that injector, because otherwise we can't just create power from nothing. So that's just something to remember. And the other way is, we've got this device called a PoE splitter. And this is a very unique technology in the industry. There's very few companies that do this, and most people are not even aware that this technology exists. Let's say you have made the investment, you've gone to a PoE switch, but you don't have a device that actually takes PoE. In this case, what you would do is you would, you take your non-PoE device and you add a PoE, well, in this case, not a PoE injector, it's actually called a PoE splitter. It looks a lot like an injector, and what it does is it takes PoE in, and then it gives you 24-volt DC out and your data out. It splits them up so that you can go into those old legacy devices and make them PoE now. I think it's a pretty neat way of going about it. You can choose to upgrade each side of the equation, whether you're upgrading your PSEs or your PDs, or you can do them both together with just a PD connected to a PSE. Or in other words, a PoE switch connected to a PoE device is your best solution. But sometimes it's not cost effective to do it that way. So here's another way to look at it. All right, so we're going to go into another poll here. Is it okay to plug in a non-PoE device into a standards-based PoE switch or injector? This is the million-dollar question. I'd love to see if you guys get the excellent score on this poll. It's actually a pretty easy question, but there is a caveat to it that we're going to discuss after everyone votes here. Looks like about half of you have voted, and we're almost there. And okay, we're at almost critical mass here. Very good. Okay, it looks like most of you have said, is it okay to plug a non-PoE device into a standard-based PoE injector? Most of you said yes, it's okay. And actually, you're correct. You see a lot of horror images about, look at these melted Ethernet ports and, my server caught on fire because PoE, those kinds of things. That actually can't happen with standard-based PoE. Now, that was the key to the question. So have no fear. It's okay to plug into a PoE switch port or a PoE injector port because there's a negotiation that happens before it actually goes into PoE mode. And we'll talk about that here in the coming slides. So it is safe to plug in if it's 802.3 AF or 802.3 AT PoE. And the reason I say that is because some vendors have taken liberty in what they call PoE. Let me give you an example here. It's actually not safe to plug in to a non-standard PoE device, especially if it's called passive PoE. Now, passive PoE works quite simply. What they do is they take an Ethernet jack and they literally plug in a power supply directly to it. There's no negotiation there, so there's no understanding of how it's going to actually work. So if you see something or hear something about passive PoE, please, please be very careful. This is not a good way to do a PoE solution. It's definitely a hack way to do it. It's inexpensive, but there are no protections, and you definitely can easily melt your devices, start a fire, all kinds of safety concerns with it. So please shy away from those passive PoE devices out there. Stick with the standard-based stuff. So you're probably wondering, how the heck does it know not to send power if I'm not a PoE or a PD device? Well, this is kind of how it works from an engineering perspective. We won't go too deep here, but if you look at the very bottom left here where it says detect range on the chart, that is where it's sending out a very, very small voltage signal across the Ethernet cable. Nothing out of the norm, nothing that most Ethernet devices wouldn't expect anyway. And that says, hey, are you a PoE device? Can I send you PoE power? And the device will answer with another blip back. And it says, why? Actually, yes, I am. And so then the PSE is ready to send power, but it says, well, I wonder how much power these guys actually want. And the PD will actually send back another blip saying, well, I'm actually, the second blip I'm sending you is just to let you know that I'm not just PoE, but I'm PoE plus. I'm even better than standard PoE, and I require more power. And then there's this very short waiting period, and then it goes ahead and hits that target voltage. Now, the target voltage is 48 volt DC. So PoE is sent at 48 volt DC. Anything outside of that voltage range, from anywhere from maybe 46 to 51, is considered non-compliant. And there are plenty of proprietary things out there that are non-compliant. We've seen some older Cisco IP phones and stuff like that that work on 24 volt DC. They call it PoE only because there is literally power being put over the Ethernet cable. But that is not standard-based PoE. So it is proprietary. You will need to use their hardware to make it work. So that's another important kind of fact. You should always check with whatever device you're going to use to make sure it does follow the standards, because that allows you to be, well, I shouldn't say thrifty, but to deploy standard-based equipment and not proprietary, potentially overinflated cost price stuff, and potentially dangerous equipment that's not following the standard. The standard is the standard for a reason, because it is safe and it does work and everyone follows that. So that's how the classification works, and then from there it negotiates how much power on a regular basis. Now, this is kind of how it breaks down. There are two standards, as I had mentioned. There's the 802.3 AT and the 802.3 AF. One's PoE plus and one's PoE. So we all started with regular PoE, and that was 15 watts of power. That's 15 watts at the port on the PSE. So the switch would have 15 watts just before it exited the port. But by the time it got down that full length of wire, you'd get down to about 12.95 watts. So, it does lose power due to attenuation, as you can imagine. And then if you look at 802.3 AT, you've got potential 30 watts of power. So, and then of course, by the time it gets down the line, down that 100 meters of cable, you've got 25.5 watts left. So what this means is that the device, or the PD that's taking power, needs to operate within those limits. You can't have a device that operates at 30 watts if you've got a long cable run. It's not going to be enough power for that device to power up. And unfortunately, there are a bunch of vendors out there that are kind of pushing the limits of power, and maybe they design closer to 26, 27 watts of power at the end, and there just isn't enough power to power their device. And one of the things they've done to get around it is they have brand labeled their own power over Ethernet injectors and sell them as a kit. Now, we figured this out over the years of doing this protocol and have some unique solutions we'll talk about here further on in the presentation to address those slightly out of spec products that are out there. So yes, PoE standard is 48 volt DC, not 24. And we're looking at a total of 30 watts as a max, but really realistically 25.5 is the max that any PD should accept today. The interesting part about the PoE Plus protocol too is that it does make steps via the protocol that's called LLDP, which is Link Layer Discovery Protocol, which is commonly used in Ethernet today. It uses that protocol to determine how far away it is, where it is, and how much power it should use on a regular basis. So you're not, I guess, allocating power where it's not needed, which means you should save power over time. So you could say that PoE it's green. Okay, so now here gets a a little bit more confusing. I know I painted a rosy picture in the beginning about, hey, just plug it in and it works. And for the most part, if you're buying equipment that's reputable, big name companies that are following the standards, that is 100% the case. You plug it in and it works. However, what we found over the years is that about 30 to 40% of devices out there are actually not quite compliant with the standard. So it becomes important to understand kind of some of these names too. There's a mode A and a mode B. There's a thing called end-span or mid-span, phantom pairs, data pairs, spare pairs. What does this all mean? Well, there's two ways to do PoE, it turns out. You can do it mode A, which is the most common way of referring to it today, and that is by using power and data over the same physical wires on that Ethernet cable. So in other words, pin 1, 2, 3, and 6 carry both the data and the power. And that's kind of how the majority of Ethernet, power over Ethernet switches work today. Injectors tend to send the power on the other wires that are not being used by data. So data is always 1, 2, 3, and 6, and then power is sent on 4, 5, 7, and 8. And that's kind of the schema for mode B. And now this is all assuming that you've got a 10-100 Ethernet cable, because if you have gigabit, then you're running data on all the wires. In which case, you still are kind of stuck to the mode A or mode B. We just have to share on those pins. So, because there was kind of this choice, you'd logically think that, well, now if I have a powered device, a device that's taking PoE, I need to know which it's compatible with. Well, it turns out that the standard says that the PDs shall accept both types of power, that it is not to accept only one kind. But we have seen in the industry that several manufacturers have implemented products that only accept one type. So it would be a good idea just to verify to make sure that the PD you choose to use, whether it's an access point, a camera, an HMI, or whatever, actually does have the ability to take both. And if it doesn't, figure out which mode it wants and make sure you plan accordingly. Now, we've kind of put a neat little product in place to address that. We have a new injector called the INJ24A that will let you do it either way. So you can select it with a dip switch. And that's important because if you just want something to work, this is the thing you get, and it's going to work with all your PDs. Not just from a pinout perspective, but from a power perspective, it's very flexible there. And we'll talk a little bit more about that in the coming slides. So it's not an exact representation, but it's a good kind of overview of how this power and data is sent. If you look on this, you've got the data pair on the top there and the data pair on the bottom there, and the red and black are being sent over those. So that's power over the data pairs. The second example is power on the unused pairs, where power is being applied to the 4 wires that are not being used by data. And then you have an example at the end here of a PoE injector being inserted between an Ethernet switch and a PD. And you see in this particular case, it's being used much like the previous one, powered on the unused pairs. This is the most common examples of PoE today. I mentioned that, okay, so we talked about power. We talked about the types of, which wires carry the power. Well, and we also talked about how maybe not everyone's following the standard. There's a thing called high power PoE that was out there that a lot of people use, but it was never standard. But unfortunately, a lot of manufacturers still built to it, and some of them still build to it today. And high power mode, since it was never a standard, is not considered supported on standard-based PoE equipment. Well, we saw too many people needing this, so we created a product that will force high power mode, the unstandard mode, which means up to about 30 watts of power on a standard 802.3 AF connection, which is the old version of PoE. Remember, the old version only went to 15. High power mode bumped that to 30 before there was a standard PoE Plus, and then PoE Plus said, no, we're going to do it this way instead. So that's what our unique little injector will do for you, but it's also a heads up to you guys too to make sure you've covered all those bases when you pick your PoE solution. Okay, so trends in automation. Okay, so you have industrial PoE devices all over the place, right? You've got gigabit things, you've got fast Ethernet things. Serial to Ethernet converters are now PoE available, so you can kind of save some money and time using those types of devices. vision cameras for motion control, access points, wireless access points, outdoor access points, WiMAX. Some cellular devices are PoE. Paging amplifiers, there's a lot of different things out there that are PoE and PoE Plus. But there's also some devices that are even higher than 30 watts of consumption, like broadband wireless bridges, HD cameras with heaters and wipers and PTZ. Those types of devices sometimes require more than 30 watts. So what do you do if they're PoE? What they've done is they've packaged their own PoE injector in the package to, or you can buy it as an accessory to accommodate for that, and those injectors will send up to 60 watts over that same wire. With our do-it-all injector, of course, we have the option for sending all that power over it with a dip switch, but it's just something to be aware of. Even though they say PoE, and it's a device that, like I had mentioned, that might be a potential high-power device, you should check to make sure that it will work with a standard PoE switch, or if it requires you to use their proprietary injector that may not be industrial. In most cases are not industrial. There are not many people that make an industrial PoE injector, or switch for that matter. Okay, so industrial PoE and PoE Plus devices are definitely on the rise. Lots of neat new things, lots of neat new HMIs and PLCs have come on board with PoE and PoE Plus. It's pretty cool. So just kind of going over those high-power PoE applications, these are the devices to look out for. PTZ cameras and outdoor wireless access points all tend to want to take a little bit more power than standard PoE puts out. Just keep that in mind. So, when we were first addressing this PoE market 10 years ago, and we thought, well, what do we need to do to make the PoE stuff that works in retail today or works in commercial applications, make them work in an industrial environment? Well, industrial environments do require PoE Plus switches because, sometimes we need to provide a little bit more power to an access point or a camera. And those are in kind of nasty environments in most cases, so we need to address that. We need to make sure we have injectors that also address that can go up to 60 watts because some of that stuff is just not following the standard. We need to make sure, of course, it's an industrial grade product that can handle the temperature and the high MBTF and have a really good warranty. And that's great warranty considering it's handling power for 5 years. And considering hazardous environments as well, Class 1 Division 2 is on its way for our products here. In just a few months you'll see a new product that has that certification and PoE in it, and that's going to be very exciting for the industry. And then lastly, of course, some products, well, we're industrial guys. We usually use 24-volt DC in our cabinet, but PoE works on 48, so how's that going to work? Well, let's talk about that here in a moment. So, we do have a lot of solutions for the market. I'm not going to go into all the products specifically, but I just want to show you that you look at our product lineup for PoE, it's pretty extensive. Whether you're doing a DIN rail switch that's managed, unmanaged, or it's a rack mount switch with lots of ports of PoE, or you just need an injector, or that neat new technology splitter to PoE-enabled devices that were never PoE in the first place, or even if you want to use a PD that's an access point, serial Ethernet converter, a camera, or even an industrial NAS. We've got a lot of products to offer in the PoE industry. But let's go back to kind of some of the advantages you can expect to see when you use Moxa that really doesn't exist in a lot of other commercial players. So, if you want to do an industrial PoE solution, these are things you should consider at least. So, PoE does send out 48-volt DC, so you would expect that the device that's providing PoE also needs to be powered by 48-volt DC, right? Well, in most cases that is true. But we do have some products that allow for 24-volt in and 48-volt out. Now, it's tricky to do this because you have to upconvert the 24 to 48, and you need to make sure you have the appropriate surge protection and upconversion and hardened upconversion components to handle that on a regular basis. We found those components and we did it that way, but it makes the product bigger. So we limit it to 4 ports because once you go to 8 ports, to do it appropriately, to do it correctly and safely, it needs to be a pretty big power circuit design, or makes the box a little too big for the DIN rail. So any more than 4 ports, we have an 8-port solution, but it does require a 48-volt power supply. But the good news is, for those of you guys that are using panels that already have 24-volt power supply available, and you just need a couple PoE ports, no problem. We've got a great solution for you. We've got several products that work on 24-volt DC. Another thing you might want to think about when you're doing a PoE switch, for instance, it would be nice that that switch keeps track of those powered devices. So, for instance, if you have a camera, the switch itself can ping that camera and make sure it's up and running. And if it doesn't receive a ping response in a timely manner, it will automatically cycle the power because it's providing power to that power device. By cycling the power, it's essentially rebooting it, and you're in good shape. And you can also do this manually by logging into the switch and forcing it to reboot yourself. Huge benefit there because, hey, now you don't have to worry about climbing up a pole and cycling power to something or unscrewing a cabinet and going with the power supply. Also, why not save some power while you're at it? If you don't have a period of time when the PoE device should be running, you can literally schedule it to be turned off during certain periods of time, save yourself some money, another green initiative. And then, of course, lastly, but probably most importantly, sometimes people aren't installing an appropriate sized power supply. If you only have 75 watts available, you might want to limit the amount of power the PoE switch is taking or providing to the PDs, because if you are trying to pull 80 or 90 watts out of a 75 watt power supply, you can brown out the switch and crash your entire network. By setting this inside the switch, it allows you to avoid those situations. We know how some installers can be overzealous or maybe want to save a little bit of money on a lower power supply. No problem. I would just suggest that you accommodate for it in a managed PoE switch. Okay, so in summary, things that you should look for in a PoE switch. You should look for some LEDs that indicate what type of power is going on, and if it doesn't have LEDs that show you, at least maybe a web GUI that can tell you what kind of power is being requested and how you're providing it. You want to be able to manage that PoE. It's always nice to have a management interface to do that, so you can do that auto reboot and those types of things. You should look for switches that have the ability to do PoE plus and maybe just a little bit more than the standard, like up to 36 watts, because sometimes those power-hungry devices are not quite following the spec 100%. And maybe even look for those injectors that go up to 60 watts just in case as well. And lastly but not least, make sure it's industrial. Make sure it's got the right amount of surge for PoE, because PoE is power, and it does tend to want to, fry the Ethernet ports if you're not using the appropriate surge protection. Unfortunately, not a lot of vendors use that. That's something that is somewhat unique to Moxa. Okay, so now we're going to go into the next poll here. As we get towards the end of this presentation, what value do you think PoE could bring to you? Well, is it the lower total cost of ownership? Is it that it's easier to cable? Does the ability to remotely reboot your PD appeal to you? Or do you just think PoE is a life-changing technology and that's something you're definitely going to do from now on because it just affects all aspects of your life? Looking at the poll here, and so a great amount of respondents. Thanks very much for responding there. Keep them coming in here. It looks like, quite interestingly, it's the easier to cable aspect that most of you are keying in on. And not only is it easier, of course, it will lower your costs. So I know it's tough to choose between those two, but yeah, in my mind, it's the best of both worlds. Of course, for me, PoE is a life-changing experience because I love it, but 13% of you also agree. But 63% easier to cable. Very good. Great poll out there. Okay, so wrapping it up, and we're just going to talk about the actual applications real quick. Oops, I skipped one here. We see a lot of different applications, but we're just going to talk about 4 real quick. For ITS, for transportation, maybe use on the highway, railway, and even some substation automation. We'll just go through those real quick. So highway video surveillance, can you imagine putting a camera up on the top of a pole that has to be wired with power and everything else? Not a great idea. So most of the system integrators do prefer using a PoE type of product for this. In the implementation of an IP network in a railway application, on board these railway cars, as you can imagine, on board is really important to save weight, make the installation easy. There's not a lot of space for wires, so PoE is a perfect solution. In fact, all the rail integrators that we're talking to today insist on taking a PoE solution approach on board. From a Wayside perspective, same thing. We've had even some solar applications. They're charging a battery inside of a cabinet. They're using PoE from there as well to power their devices, whether it's wireless or cameras. It's a very simple application. Parking lots and everything else, we see a lot of easy installations there as well. And last but not least, probably a good majority of who's on the phone with us is machine builders. Let's reduce the cable clutter in that enclosure, reduce the heat in the enclosure, allow for that remote rebooting of the PoE device if you want to troubleshoot or cycle power to things remotely. It's a faster install, you're adding redundancy and a lower redundancy on a power perspective, and you're lowering the cost. So it's really a pretty big win across the board there. So let's sum it up. Well, with PoE, you can save money, you can save time, you can save cables, and you can reduce heat and save money on your power bill. All keeping in mind that with the right knowledge, PoE is a great solution. And what I mean by that right knowledge is maybe going back and looking at what a PD is, what a PSE is, what's the power, what type of mode is it taking, mode A and mode B. If you know those three things, you will easily be able to implement a PoE device. And with that, we're coming to the end of the presentation, but I'm going to go ahead and address some of the questions right now. So let's look at what we have to have for questions here. Marty?
All right, now we're going to open up for some questions. We do have some in the queue. So the first question is from Simon. PoE power control. Does the PD need to be battery powered to be able to start the negotiation? So Jim.
That's a great question. Actually, the PDs do not need to be battery powered for that negotiation to start. The voltage that's being sent over the PoE, I guess the Ethernet cable, the PoE negotiation signal, it goes up to about 10 volts, and that's enough to energize the PoE chip on the other side. So the PD has a chip that's expecting power on those special pins, and that's plenty of power for it to power up and send back a signal, yes, I'm PoE. Good question.
Okay, great. The next question we have from David. Are all standards-based PoE, is it 48 volts? Jim.
Well, traditionally, PoE as it relates to 802.3 AF and 802.3 AT is 48 volt DC, and that is considered the standard. There were some substandard things that did 24 volt DC, but again, they can call it PoE. They just can't call it 802.3 AT or 802.3 AF, which is the standard for all PoE.
All right, another question from Simon. Can PoE be intrinsically safe for hazardous locations?
Well, that's another good question here. So, the short answer is yes, because you're not creating sparks if you were to arc those connectors together. We are submitting for the Class 1 Division 2, so that is a way of being intrinsically safe. And also, the circuit itself is designed to look for short circuits. So if it sees that there's any anomaly in the way the power is being delivered, it will right away just cut off that request for power and will turn it off immediately. So we're talking 48 volt DC at not so high of amperages. So you've got the combination of that plus the power circuit protecting against it. You have a very safe solution to be used in hazardous environments and locations. Now, I wouldn't say you want to use it in a Class 1 Div 1 area, but Class 1 Div 2, sure, that's no problem.
Okay, another question from Simon. Jim, can you explain why 4 wires for power?
Sure, no problem. That's an easy one. And Simon, thank you for all the good questions. This is great. Obviously, PoE is of great interest to you. The 4 wires for power is simply because most Cat5 cables are running on 28 gauge wire. So, it's pretty thin. So you definitely want to use 2 wires for positive, 2 wires for negative to provide up to 30 watts of power. If you only had 2 wires as a whole, you'd be maxing out close to 18 watts as the TIA says, from a spec safety standard. So by putting it across multiple wires, you are allowing for more current to flow.
Great, thanks, Jim. And lastly, what is the maximum throughput of PoE? And thank you for the question, Irene.
All right, Irene, the maximum throughput for PoE is the maximum throughput for your data without PoE. So there is no change in the amount of bandwidth when you use PoE. It's just something that exists on the line that it's transparent. You're not aware of it. So if you have a 10-100 connection, technically your throughput is 100 meg full duplex, so you have 100 meg each direction. If you're using gigabit, same thing, gigabit. You can run PoE during while doing the data transfer, no issues whatsoever. So no limitation there. Fire it up.
Great, thank you, Jim. And we will definitely be sending the recording of this presentation as well as the slide deck out to you all shortly. Thank you, everyone, for attending, for your interest and participation. Next month, our webinar topic will cover Modbus protocols. We'll send you an invite and look forward to seeing you there. Lastly, please take a minute before logging off to fill out our survey, as we really value your input and feedback. Thanks again for tuning in, and have a great week.
Thanks, everybody.